Hi, we are from Group 11 from Session 5, BDA 20103, Dynamic. We want to discuss about our case study, sliding window concept. There have five total members groups, which is Muhammad Siraj, Muhammad Akil, Aminur Naim, Muhammad Firdaus, and Isaac. Let's invite Muhammad Firdaus to discuss about introduction.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus binti Nandis. Matric number CD230009. So, for introduction, dynamics, a branch of mechanics, studies forces and their effect on motion. Essen- Essential for understanding and predicting the behavior of object. It is divided into kinematic and kinetics, which together provide a framework for analyzing complex mechanical systems. This research uses the example of closing a sliding window to demonstrate the practical application of dynamic principles. Despite its simplicity, the exercise involves a complex interaction of forces, moment, and motion type, illustrating fundamental dynamic concept. The study examined the kinematic and kinetic aspect of a window's motion using Newton law and energy concept to analyze translational movements. The approach underscore, underscores the importance of dynamic engineering analysis and design while enhancing theoretical understanding.
For the description, a closing sliding window that functions in the dynamic kinematic of a rigid body produce a frame of reference that change over time. Elements focusing on the most recent time steps or set of data point in the motion analysis of the system. This technique efficiently manage computer resource by distance orders, less real data while enabling real-time tracking of the rigid body position, velocity, and acceleration. Alright, a static or full history approach may miss short-term pattern or anomalies that the window slides forwards in time, capturing fresh data on the body's motion and allowing the analysis to adjust the shifting dynamics. Now, case study in methodology. Alright, so our group devised a simple experiment to better understand what is involved when a closing slide window act in dynamic concept and what the motion react like translation or rotation in relative motion analysis velocity. So as you can see, right, VB is the velocity of point B and VC is the velocity of point C and omega VEC is the angular velocity of link BC and RB is the position vector from C to B. So we need to know what the equation is suitable to solve this problem. Alright.
Hi, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Akil bin Irazi and my matrix number is CD230153. And for my part, which is the calculation and analysis. And let's move on to the question. The sliding window is being closed, moved at 7 meter per second down the inclined groove. Determine the angular velocity AB and BC at the instant shown and determine the velocity at B. Before we go further, let's first analyze the diagram. The diagram shows already stated that omega AB is rotating with the fixed axis at A uh, clockwise. Okay, for the calculation, we first put the equation of velocity, which is VB equals to VC plus omega BC uh, times RBC. Don't forget that omega BC times RBC is a cross product. So we have to put in the Cartesian form. We cannot solve using this full velocity equation yet because we are lacking in information. So let's move on in one by one. So first of all, we have to search for the VC. Let's continue. VC is equal to 7 sine 30 degree I minus 7 cos 30 degree J. And RB, we know already that RBC is 3 meter. So after we gathered some information that are useful for our calculation, let's continue putting the VC information into the velocity equation. Uh, so we got this. You can see in the slide that VB is equals to VC plus omega BC times RBC. Same. So it's because we need to find the velocity. We just put the VB, or we can just put VB is equal to omega AB times RBA RAB. Sorry, as you can see from the right side, the right side of the slide bottom, you can just put uh, omega AB times RAB. So after that, we can put the VC equals to the 7 sine, 7 sine 30 degree and all that into the velocity equation. And after that, we can split it into I components and J components. And don't forget, it is cross product. We have to remember the cross product formula, which is K times J is equal to negative I. So after we finish all that, we can finally uh, find the needed information, which is the omega BC and VB. And because of we get the BC information, we can put it in the formula at the left at the right side bottom, which is VB equals to omega AB times RAB. and, and we can find the omega AB, which is equals to 3.031 radian per second. And omega BC, it is equal to 1.167 radian per second. Sorry. I think that's all for the calculation. Thank you.
Assalamualaikum, my name is Aminul Naim bin Kama Afendi. My numeric number CD230202. Today I want to present about discussion. From our group has been decided to look at a sliding window concept, rigid body kinematic. It's a basic idea, a classical mechanic. Kinematic of rigid body in a dramatic illustrate the motion of the window without taking a force generating the motion into the effect. So the calculation of the sliding window kinematic on the inclined groove involves setting up the problem with given parameter, applying the fundamental velocity equation VB equal VC plus modulus BC multiplies RBC, all which demonstrate the application of vector equation and trigonometry in involve a 2D rigid body kinematic problem. Compared to static approachment, this method allows for more response and enhanced processing since all the window to grow, shake and compass completely respond to significant patterns, anomalies and paradefined conditions found in the data stream. To achieve efficient performance in a real-time situation, the imitation of this system necessarily declares the balance act between processing efficiency and sensitivity, ultimately providing a strong instrument to revising instances that harder analytical methods may overlook.
Hi, my name is Isaac Prukripa. In conclusion, we focus on understanding how forces and motion interact by applying Newton law and energy concept. This allows us to model the window behavior, capturing both its translational and rotational movement. Our case study involved a robotic arm used in high-precision manufacturing. By applying this dynamic principle, we saw significant particle benefit. The robotic arm real-time motion analysis improved, error rate dropped, and overall productivity increased. This project highlights the importance of dynamic analysis in engineering. It shows how understanding and applying this principle can lead to smarter, more efficient, and more accurate solutions in real-world application.